A given equation of hyperbola, given equation of hyperbola is 7x squared minus 4y squared equal to 28. So this is marked as equation 1. Now on further simplification of this equation we get x squared by 2 squared minus y squared by root 7 whole square equal to 1. Now we can draw this hyperbola. X prime, origin, y prime. This is one part and this other. Now the vertex A is 2, 0 here and A prime minus 2, 0. Now what we find here, find the equation of tangent perpendicular to the line. There's a line here, equation of given line to which the tangent is perpendicular. So equation of given line is y equal to minus x by 2. Now that is something like this. This is the equation of line given to us, to which the required tangents are perpendicular. Why I'm saying tangents? Because you can easily understand here two tangents are possible. Tangents to which the line is perpendicular is this is the line. Now slope of the given line, slope of given line is minus sign. Now we take a point of contact here, Px1, y1. Point of contact where the tangent will be drawn, Px1, y1. Now on differentiating equation 1, on differentiating equation 1, we get ddx of y equal to 7x by 4y. Therefore, ddx of y at the point of contact x1, y1 equal to 7x1 by 4y1. So this is the slope of the tangent which I've got. Now, as tangent is perpendicular to the line, is perpendicular to the line, y equal to minus x by 2. So 7x1 by 4y1 into minus half equal to minus 1. And this gives us y1 equal to 7x1 by 8. Now we have already told Px1, y1 is a point of contact, so that will satisfy equation 1. Now Px1, y1 will satisfy the equation 7x squared minus 4y squared equal to 28. This implies 7x1 squared minus 4y1 squared equal to 28. Now, just now what we have got, that y1 equal to minus 7x1 by 8. Now this we can mark as equation 2. Now we can say using equation 2, what we can write? 7x1 square minus 7x1 whole square by 8 square into 4 equal to 20. Now from this simplification, we get x1 equal to plus minus 8 by 3. And from equation 2, we get y1 equal to plus minus 7 by 3. Therefore, equation of tangents y minus 7 by 3 equal to 2 into x minus 8 by 3, which on further simplification we get y equal to 2x so y equal to 2x minus 9 by 3 and y minus y plus 7 by 3 equal to 2 into x plus 8 by 3. So this will give us y equal to 2x plus 9 by 3. So this is the two equation which I get. One is y equal to x minus 9 by 3 and that is y equal to x plus 9. Equation of circle. Equation of circle. X square plus y square equal to a square. We mark this as equation 1. Now let's say the line touches the circle. So equation of line is Lx plus My plus n equal to 0. Now we have to find the condition that this line touches this circle. Line touches the circle means the line will act as a tangent. So what we do here, first of all, we find the equation of tangent to the circle. Now we take the circle here. This is y, this is x, this is x prime, origin, y prime. Radius of the circle, a comma 0, and here minus a comma 0. Here 0 comma a. Here 0 comma minus. Now the tangent to the circle, this one, at the point we have taken the point of contact as x1 y1. So point of contact px1 comma y1. On differentiating equation 1, we get ddx of y equal to minus x by y. Therefore, ddx of y at x1 y1 equal to minus x1 y1. Equation of tangent is y minus y1 equal to slope x minus x1. Now, which on further simplification gives x1 square plus y1 square. Now, since this is a point of contact, it must satisfy the equation of the circle. So we write the equation of tangent as x1 plus y1 equal to a square. As px1 comma y1 on the circle, it must satisfy the equation of circle. So we got the equation of tangent as x square xx1 plus y1 equal to a square, which can be done directly also while doing the MCQ. That is, x square has been expressed as xx1, y square as yy1, and a square as it is. Now, since this tangent and this line should be identical, that is what we mean to say the tangent line marked as 3 and this line should be identical. Equation 2 and equation 3 should represent the identical line. So we can write L by x1 equal to m by y1 equal to n by minus a square. This gives us x1 equal to minus a square L by n and y1 equal to minus a square m by n. Now, x1 comma y1 satisfy the equation of circle. So minus a square L by n plus y square equal to a square. Now this one further simplification, we get a square into L square plus m square equal to n square. Now which is the required condition? Equation of circle is given as equation of circle is x square plus y square plus 2gx plus 2fy plus c equal to 0. And the line which is touching this circle, equation of line touching the circle is Lx plus my plus n equal to 0. We take the equation of circle as equation 1 and this one as equation 2. Now from 1, we can simplify this as x plus g whole square plus y plus f whole square equals to g square plus f square minus c. Now we can shift the origin and take a new variable. Let u equal to x plus g, v equal to y plus f. So the just the concept of origin shifting. So we have taken this u as x plus g and v as y plus f. Now equation 3, I have marked this one. So equation 3 can be represented as, equation 3 can be represented as u square plus v square equal to g square plus f square minus c. And we mark this as equation 4. Now, since we have simplified this one, corresponding the line will also take a different form. So equation 2 takes the form, equation 2 takes the form LU plus MV equal to LG, which we mark as 5. Now, this is a very simplified equation. Now we can differentiate this equation. We can take a point of contact now. So we consider point of contact taking P U1 comma V1 as a point of contact. As a point of contact. Now on differentiating equation 4, what we get? dd u of v equal to minus u by v. Therefore, dd u of v at u1 comma v1 equal to minus u1 by v1. Therefore, equation of tangent. Therefore, equation of tangent is v minus v1 equal to minus u1 by v1 into u minus u1. Now, if we simplify this, we get v1 plus u1 equal to g square plus f square minus c, as u1 v1 is point of contact. Is point of contact. We take this one as equation 6, which is a tangent to the circle 4. Now that tangent and this line should be identical. That is equation 6 and equation 5 should be identical. Equation 6 and equation 5, or equation 5 and equation 6 should be identical. Should be identical. So u1 by L equal to v1 by m equal to g square plus f square minus c whole divided by lg plus mf minus n. Now from this, we get u1 equal to L into g square plus f square minus c whole divided by lg plus mf minus n. v1 equal to m into g square plus f square minus c by lg plus mf minus n. Now this will satisfy, since this is a point of contact, it will satisfy the equation as u1 comma v1 is a point of contact. Point of contact. So it must satisfy the equation. u1 square plus v1 square equal to g square plus f square minus c. Now, on simplifying we get L square into g square plus f square minus c whole square by Lg plus mf minus n whole square plus m square into g square plus f square minus c whole square divided by Lg plus mf minus n whole square equal g square plus f square minus c, which on further simplifying L square plus m square into g square plus f square minus c equal to Lg plus mf minus n whole square. Equation of the curve given as a parabola. Equation of the curve parabola. Y square equal to 4ax, which we represent graphically y x y prime x prime origin. Now this is y square equal to 4ax graph. It is said a line Ls plus my plus n touches this parabola. Line Lx plus my plus n equal to 0 touches the parabola. Now we consider that this line touches this parabola at some point px1, y1. So px1, y1 is a point of contact. So we consider px1, y1 as point of contact. So if we draw a tangent, because if it touches the parabola, that means it's a tangent. So if we find the equation of tangent at this point, and this line should be identical. So here we try to find the equation of tangent at this point. Now for that slope of the tangent equal to slope of the curve at x1, y1 equal to ddx of y at x1, y1. Now this gives us (2a by y1) as a slope. Now once we have got the slope, we can find the equation. We have got here the slope, so now we can find the equation. So equation of tangent y minus y1 equal to slope into x minus x1. Now which one simplification we get? Y1 minus y1 square equal to 2ax minus 2ax1. Now x and y is a point of contact, so that means it will satisfy the equation of the parabola. Since this point is lying on the parabola, it must satisfy the equation of the parabola. Now, when it satisfies the equation of the parabola, that means y1 square equal to 4x1. So what we do, we keep here as equation 1, and we say as px1 comma y1 lie on the parabola, so it must satisfy the equation. It must satisfy the equation of parabola. That means y1 square equal to 4ax1. Now this is equation 2 we take. Therefore, from 1 and 2, from 1 and 2 we can write y1 equal to 2a into x plus x1. Now that is the equation of the tangent which we have got. Now someone can think it in this way also as a shortcut method, but that is applicable only for MCQ. Y square equal to 4x, as I told you, that you can express this y square as y1, and this one 2a into 2x, which will be 2x can be written as x plus x1. That can be applied, but this is only for MCQ sums, not for the proper sums, which you have to do it in the board exam. Now we have got this one as a slope of the tangent, as the equation of the tangent. Now this equation of tangent which we have got here, equation 3, and the line Lx plus my plus n should be identical. That is this equation, that is from equation 3, or if we simplify equation 3 or we write it in the proper format, what we get, it is twice x minus y1 equal to 2ax1. Now if we compare Lx plus my equal to minus from given line equation, from given line equation. Now on comparing, we get 2a by L equal to minus y1 by m equal to 2ax1 by n. Now from this we get x1 equals to n by n, y1 equals to 2am by n by l. Now since the point is satisfying as by the equation 1, that is from equation 2, we get 2a by m whole square equal to 4an by l, and from that we get am square equal to nn, which is the required condition. Equation of the given curve is x square by a square plus y square by b square equal to 1. With an ellipse. Now this is the ellipse. Here we have got the vertex as a comma 0 and this one 0 comma b. Now a line, equation of the line touching the ellipse, equation of line touching the ellipse. Lx plus my plus n equal to 0. Now, when it will touch the ellipse, that will act like a tangent. Suppose we consider this is the line which is touching the ellipse. Now, when it's touching the ellipse, it is acting like a tangent. So now we can find the equation of tangent at this point of contact. So we consider P x1 comma y1 be the point of contact. Now this is a differentiable function. So we differentiate this one. It's equation 1 on differentiating equation 1 with respect to x. So we get ddx of y equal to minus b square x by a square y. Now we are finding the slope at the point x1 comma y1. So this becomes b square x1 by a square y1. Now once we have got the slope, we know the point of contact, we can find the equation of the tangent. So equation of tangent is given by y minus y1 equal to minus b square x1 by a square y1 into x minus x1. Now this means y1 by b square minus y1 square by b square equal to minus x1 by a square plus x1 square by a square. Now this gives us x1 by a square plus y1 by b square equal to x1 square by a square plus y1 square by b square. Now since x1 is a point of contact, it must satisfy the ellipse and we should get this equal to 1. That is, after this we can write that x1 by a square plus y1 by b square equal to 1 as px1 comma y1 is point of contact. So it must satisfy the equation. So it must satisfy the equation of ellipse. So x1 square by a square plus y1 square by b square equal to 1. And we have got the equation of tangent. Now this could have been thought in this way from MCQ point of view, that is if you have x square, as I told you, we express as x1 by a square, y square, y into y, so y into y1 by b square equal to 1. But this can be applied only in case of MCQ format. Now we mark this as equation 1. An equation of given line as Lx plus My as 1, we compare with that line. So on comparing equation 1, on comparing equation 1 with Lx plus my plus n equal to 0, we get L by b square x1 equal to m by a square y1 equal to n by minus a square b square. From this we get x1 equal to minus a square L by n, y1 equal to minus m b square by n, which will satisfy the equation of ellipse of the given ellipse. That is x1 square by a square plus y1 square by b square equal to 1. So we get here a square L square by n square plus b square m square by n square equal to 1. And from this we get n square equal to a square L square plus b square m square. And according to the required condition, plus b square m square equal to n square, which is the required condition. Here, the given equation of curve is x square by a square minus y square by b square equal to 1. Hyperbola. We represent the hyperbola in graph first. X prime origin y prime. Now we know here the vertex a comma 0. Here a prime minus a comma 0. Now here the line Lx plus my plus n equal to 0 touch the hyperbola. We consider that it is touching, line is touching the hyperbola at this point. When this line is touching the hyperbola at this point, that means at this point it acts like a tangent. So if it acts like a tangent, then the tangent equation and this equation should be identical. Equation of the line, which touches the hyperbola, is Lx plus my plus n equal to 0. We mark that as equation 1. So this will act as a tangent. Now tangent at which one? At px1 y1. So that is the point of contact. So here we have point of contact P x1 y1. Now slope of the tangent at this point we can find out. The slope of the tangent and slope of the curve at this point is same. Our intention is to find the equation of tangent. So we have taken here point of contact as p x1 y1, which will satisfy the equation, of hyperbola, satisfy the equation of hyperbola. So x square by a square minus y square by b square equal to 1. x1 square This satisfies the equation of the hyperbola, so x1 square by a square minus 1 square by b square equal to 1. We mark that as equation 2. Now to get the equation of tangent, we need the slope of the curve at this point. Because slope of the curve at this point and tangent curve and the slope of the tangent is same. Slope of tangent is equal to slope of the curve at p x1 y1, which is gdx of y at x1 y1. Now that gives us b square x1 by a square y1 on differentiating this curve first, and then we are substituting x1 y1. So this is the slope of the curve, slope of the tangent, slope of the curve at the point this one, which is the slope of the tangent. Now from this we can find the equation of tangent. So equation of tangent. Y minus y1 equal to b square x1 by a square y1 into x minus x1, which on further simplification we get y1 minus y1 square by b square equal to plus x1 by a square minus x1 by a square. Now this gives us x1 by a square minus y1 by b square equal to x1 square by a square minus y1 square by b square equal to 1 by equation 2. So we got the equation of tangent as x1 by a square y1 by b square equal to 1. Now that is the equation of tangent to hyperbola. Now this can be thought as in shortcut x1 by a square, like we are multiplying x square means x1 by a square minus y1 by b square equal to 1. So someone can think it in this way also for finding the equation of tangent very fast. Now this equation and the equation 2, so we mark this as equation 3. Equation 1 and 3 should be identical. As they represent the same line. So on comparing the coefficient we get L by x1 by a square equal to m by minus y1 by b square equal to n by 1. Now this keeps on further simplification. A square L by x1 equal to minus b square m by y1 equal to n by 1. Now this gives us x1 equal to a square L by n, y1 equal to minus b square m by n. Now x1, y1 will satisfy equation 2. So we write here which will satisfy equation 2. And this gives us a square L square by n square minus b square m square by n square equal to 1. So a square L square minus b square m square equal to n square. Now this is the required condition which you need to find.